Hello, hello, testing. Hello, good morning, or afternoon, or evening, wherever you are. I'm trying something kind of different today. I'm gonna be studying system design. I have no idea how this will work on stream. It's not gonna be very interactive. I think I'm gonna be silent most of the time, because I'm just taking notes. But I need some peer pressure to study this. I've been meaning to read this. Well, I started it, I read the first part of it, but I need some more motivation to continue. So I'm streaming this. Alright, here we go. In case you're wondering, system design is like, how do you, I don't know, design components of an app together? Like, how do you design what the smaller components of an app are? The database, the servers. That's all I know. Okay, here we go. Single server setup. Web app, database, cache, etc. Okay, so the flow is users access websites through domain names such as api.mysite.com. Usually the domain's name system is a paid service provided by third parties and not hosted by our servers. IP address is returned to the browser or mobile app. In the example, IP address is this. Once IP address is obtained, HTTP requests are sent directly to your web server. Okay. Web server returns HTML or JSON response for rendering. Okay. The traffic to your web server comes from two sources, web application and mobile application. Mobile application is the communication protocol between the mobile app and web server. JSON is commonly used API response format to transfer data due to its simplicity. An example of API response in JSON format is shown below. I didn't know that, by the way. I thought web apps and mobile apps would have used the same protocol. I guess HTML and JavaScript for presentation. I would have assumed that mobile does the same too. Maybe for a Chrome mobile app it does it. Transfer data. Okay. Mobile uses JSON, huh? Okay. One server is not enough and we need multiple servers, one for web/mobile traffic, and the other for database, separating the mobile traffic, web tier, and database data tier servers allows them to be scaled independently. Okay. I feel like maybe this is important to note down. Okay, so what happens when you fire off a request, from when the user fires off a request to our server? User fires request to server. Man, you really cannot tell, but I'm taking notes right now. Okay, so you get the IP address from the DNS servers. Yeah. Okay. So first you make a call to the DNS service. IP address returned. And then what happens after that? The user can fire off an actual request to the correct IP address, HTTP, user fires request to IP address. Feel like that's important. And this uses HTTP. And then our servers return HTML or JSON for rendering. Okay. HTML or JSON. Okay. So JSON is the most commonly used response format for mobile. It's kind of unintuitive. JSON is for mobile. Oh, the sun is blinding me at the moment. Let me flip up my blinds. Brian VT says, "Congrats on your battle, chat." Oh, thanks, Brian. Wait, how did you know I won? From Discord or the video? By the way, hello. I'm studying system design. It's gonna be a quieter stream because I'm just literally taking notes and studying. But yeah, how are you doing, Brian? Oh, the video. Oh, the video. That was the most I've seen your heart rate go up. The video. Dang, you watched it fast. It's been 23 minutes since it's out and you finished watching it. I think it hit 80 ppm. Yeah, that's really fast for me, isn't it? Haha. From the usual 50 ppm. That's pretty funny. But yeah, I think Circuit is indeed like the most stressful contestant I've had so far. She's like so fast. She did the first problem in 5 minutes, did the second in like 10 minutes, which really made me panic. I thought I was gonna lose really badly. So I engaged gear 2. But at what cost though? At what cost? I probably shaved 10 years off my life thanks to that. My chest actually did not feel good after that battle. But hey, I learned a lot. The power of brute force. But yeah, there's other battles coming up in the future. On Saturday, I'm facing off against an actual IRL software engineer. It's gonna be interesting. I'm actually probably gonna get my butt kicked this time. No matter how many gears I engage. Yeah. Oh well. You always learn from these experiences. One server is not enough, we need multiple servers. One for web mobile traffic, the other for the database. It's been so long since my JavaScript class, but it looks fun. Wait, does it look fun? I guess you're actually like learning what goes behind an application, which I'm not good at. Yeah, there's not really any code here. It's just how do you design an application so that it doesn't fail. Like there's your users, they're querying your web server, which serves them information. And then there's the database that can store information. Yeah, I barely understand it myself, to be honest. One for the database. Which database to choose? Oh, time to write down some notes. Okay, so there's the relational kind, RDBD. Wait, RDBMS. Sounds like I like problem solving in general. Oh. Yeah, I kind of get that vibe from it. You really like to try new things, right? Get Waludo working, Nodes, Blender. Yeah, you seem like you really try to explore things and get it to work. RDBMS, not to be mistaken with BDSM. Oh. RDBMS, SQL. The most popular ones are these. Relational databases represent and store data in tables and rows. RDB, SDM. Reified says, hi chat. Hi Reified. How you doing? Hey, I'm doing something really different today. It's going okay. Yeah, I started passing some second round interviews for the first time. So the next stages are system design interviews. So I'm studying. I'm so nervous. But yeah, last week was kind of a big deal for me. I finally passed some second round interviews. So now we're studying system design because that's what they're gonna test. Pain. So pain. But yeah, 9 o'clock is still gonna be lead coding. I'm thinking about getting up early and doing system design study. Yeah. That's pretty much what's going on. Okay, relational databases represent and store data in tables and rows. I feel like that's important. Tables. You can perform join operations using SQL across different database tables. Non-relational databases are also called NoSQL. Okay. Or NoSQL. SQL. Maybe it's for the best that there's no SQL, because SQLs always suck. Oh. Popular ones are these. I've actually used this one before. From AWS. These databases are grouped into 4 categories: key value, graph, column stores, document stores. That means nothing to me. Join operations are generally not supported. All right. Can join, no join. Okay, so if you don't have to join, I guess it's faster, right? You don't have to look through many other tables. But then you can't sort of make the information more efficient by normalizing it, I guess. For most developers, relational databases are the best option because they have been around for over 40 years. Historically, they have worked well. However, if relational databases are not suitable for your specific use cases, it is critical to explore beyond relational databases. Non-relational databases might be the right choice if your application requires super low latency. Oh, that seems important to write down. Okay, this doesn't say, but it's super low latency because you don't have to do any joins, right? You just duplicate all of your information locally. So no joining. I guess that makes sense. All of your information is stored in one place, so you only have to query one spot. Your data are unstructured or you do not have any relational data. Okay. So not table data. You only need to serialize and deserialize data, JSON, XML, YAML, etc. Wait, why? You only need to serialize and deserialize data. Why? I know why this is good, because this is not table format, right? You only need to serialize and deserialize data. Wait, this makes no sense to me. Why? What's the reasoning behind this? You only need to... Dragon says, content seems familiar. Is this Alex Shu's book? Yeah, it's Alex Shu's. It's System Design Interview and Insider's Guide by Alex Shu. I think it's first edition. Yeah. I found the PDF online. You only need to... Wait, do any of you know why this is the case? Why is this an advantage of NoSQL tables? You only need to serialize and deserialize data. Like, why is this an advantage? I know why, if you're using JSON, XML, and YAML, you use NoSQL because it's not in table format, right? You can easily just plug it into, well, yeah, you don't have to convert it into table format. You can just store it directly. Wait, is this what it means? You only need to serialize and deserialize data. Maybe I'm missing something. What does serialize mean? Serialize data definition. Converting an object into... Okay, so you're converting an object directly into a format that you can store. Is that what it means? Constructing a data structure or object. Okay. Converting an object to a stream of bytes. Okay, I guess that makes sense. You don't need to... Yeah, you don't need to actually convert it to table format. Okay, you need to store a massive amount of data. You need to store a massive amount of data. Wait, why? I don't get it. You need to know. Isn't this an advantage of relational databases? Because you can normalize the data. Like if everybody refers to the same, I don't know, job, you can have everyone just store the ID of the job and have it point to whatever job it is in the job database. You need to store a massive amount of data. No SQL versus SQL. Which one is more storage efficient? You need fast availability of big data. Data is stored together, not separately. Document key value. Unstructured data like documents or JSON. Oh, large data. NoSQL databases are better suited for large amounts of data, simply because they are often designed with horizontal scaling in mind, allowing them to be easily scaled out across multiple servers. Oh, okay, so you can more easily horizontally scale. Okay. DynamoDB, yes. Okay, so they're better for horizontally scaling. All right. Okay, large amount data because better horizontal scaling. Why are NoSQL better for large amounts of data? Scalability. I see. Traditional relational databases are designed to work on single servers. Okay, that makes sense. Scalability. Okay, that seems to be the consensus. Vertical scaling versus horizontal. Vertical scaling, referred to as scale up, means the process of adding more power. CPU, okay. Horizontal scaling, referred to as scale out, allows you to scale by adding more servers into your pool of resources. Okay. Yes, vertical scaling has a hard limit. Vertical scaling does not have a failover or redundancy. Yeah, okay. Yeah, okay. Horizontal scaling provides redundancy and failsafe. Load balancer. Load balancer. This sounds important. Evenly distributes incoming traffic among web servers are defined in a load balance set. Okay, so distributes traffic among horizontally scaled web servers. Yeah, okay. Distribute traffic among web servers. Okay, so the user gets the IP address from the DNS, it sends it off to the load balancer, and the load balancer distributes it to the servers. Okay. Users connect to the public IP of the load balancer directly. I see. So the load balancer has the public IP. The web servers have private IP now. Public IP, private IP. Okay, we successfully solved no failover issue and proved the availability of the web tier. Details are explained below. If server 1 goes offline, all the traffic will be routed to server 2. Yes. If the website traffic grows rapidly and 2 servers are not enough to handle the traffic, the load balancer can handle this problem gracefully. You only need to add more servers to the web server pool, and the load balancer automatically starts to send requests to them. Now the web tier looks good. What about the data tier? Database replication, okay. I need to sharpen my pencil. Give me a moment while I plug my pencil sharpener in. Oh, okay. If all went well, you're going to hear a electric pencil sharpener go off. Okay, that was loud as heck. Thanks for bearing with that. I only have a limited amount of sockets. So I had to unplug the fan and temporarily to plug the pencil sharpener in. That's why it's a hassle. Okay, database replication can be used in many database management systems, usually with the master/slave relationship between the original and the copies. Okay, database replication. Excuse me. Replication. This is much easier to write with now that the pencil is sharp. A master database generally supports write operations. Oh, okay. Only supports write. A slave database gets copies of the data from the master database and only supports read. Oh, okay. All the data modifying commands like insert, delete, or update must be sent to the master database. Most applications require a higher ratio of reads to writes. Thus, the number of slave databases in the system is usually larger than the number of master databases. I see. Usually more because reads more. Okay, so there's your web servers. There's your master DB for writes, there's reads, DB replication, okay. Advantages of DB replication, better performance, all writes and updates happen in master nodes, whereas read operations are distributed across slave nodes. This model improves performance because it allows queries to be processed in parallel. I see. Yeah, parallel reads, makes sense. Reliability, if one of your database servers is destroyed, yeah, it'll still be around. High availability, by replicating data across different locations, your website remains in operation even if a database is offline, as you can access data stored in another database. Load balancer help to improve system availability. We ask the same question here. What if one of the databases go offline? Yes, redirect the read operations, replace the old one. If the master goes offline, the slave will be promoted to a master. That never happens socially. This analogy doesn't work. All the database operations will be temporarily executed on the new master database. A new slave will replace the old one for data replication immediately. Okay. Yeah, the data in the slave database might not be up to date. The missing data needs to be updated by running data recovery scripts. Okay. I mean, for most, I guess for maybe many cases, just trying to promote the slave to a master fast enough should be enough, right? How much can a few seconds take, you know? Though maybe in some other applications, it makes the world. Okay, there's your user. It gets the IP address from the DNS. It goes to the public IP address of the load balancer. Load balancer distributes it upon the servers. The servers query the master DB for writes and the slave DB for reads. Slave DB keeps replicating the master DB, okay. Yeah, okay. Cache. A cache is a temporary storage area that stores the result of expensive responses or frequently accessed data in memory so that the subsequent requests are served more quickly. Okay. Temporary storage layer, much faster than the DB because it's in RAM, right? RAM is way faster than cold storage. Reduce DB workloads. Scale the cache tier independently. Okay, time to add cache to my notes. Cache. Reduce DB workloads. Yes, we have to make it easier for the slaves. They don't work hard enough already. The DBs, I mean. Okay. Web server first checks if the cache has the available response. If it has, send it back. If not, query the database, store the response in the cache, and send it back to the client. Okay. So if cache has response, return it. Else, query the DB storing cache, and then you return it. This caching strategy is called a read-through cache. Read-through strategy. Okay. Okay. Memcached APIs. Considerations for using cache. Decide when to use a cache. Consider using cache when data is read frequently but modified infrequently. Since cache data is stored in volatile memory, a cache server is not ideal for persistent data. For example, if a cache server restarts, all the data in memory is lost. Thus, important data should be saved in persistent data stores. Okay. Volatile memory. Yeah, RAM. I guess it makes sense if you have more reads than writes, right? Because if you write too much, then the cache becomes less effective. Some of the data might become outdated. Expiration policy. Yeah. Don't make the expiration date too long as the data can become stale. The expiration date. Versus data to stale. Consistency, keeping the data store and cache in sync. Data modifying operations on the data store and cache are not in a single transaction. When scaling across multiple regions, maintaining consistency between the data store and cache is challenging. Okay. Consistency between the DB and the cache. Maybe that's a read for the future. Mitigating failures. A single cache server represents a potential failure, so a single point of failure. Multiple cache servers are recommended to avoid this. Another recommended approach is to over-provision the required memory by certain percentages. This provides a buffer as the memory usage increases. Okay. Eviction policy. Once the cache is full, any request to add items to the cache might cause existing items to be removed. Least recently used. Okay. CDN is a network of geographically dispersed servers used to deliver static content like images, videos, CSS, JavaScripts. Content caching. Okay. Content delivery network. So it's like caching except for images, videos, CSS, JavaScript. I hit the time that I wanted to spend for system design study today. 9 a.m. is going to be for LeetCoding. I'm going to switch gears really quickly. Twitch viewers might... We're just going to pause for a minute. YouTube viewers, we might switch streams altogether. Give me a moment, yeah.
Post, yeah.
Okay, so on Twitch, I just need to switch the title, right? Twitch isn't too bad for this. Okay, so I just need to switch this to LeetCoding every day. Day 35. Very nice. And then on YouTube, I might switch streams altogether.